Good morning, everybody. Today I'll be taking you about the health and risk of microplastic exposure, an issue that has become increasingly urgent in the public health. Microplastics, also known as MPR, are plastic particles less than 5 millimeters in sizes, and we discover them in every more places in the human body. Now, this presentation will walk you through how we're exposed, what does our health, and what does this matter, not just environmentally, but also biologically and medically. So please, hopefully you enjoy it. You like it. So as we commonly talk about, microplastics are either formed from the breakdown of larger plastics or manufactured for the use of products like cosmetics. Yes, ladies, you guys that use cosmetics. Now, humans are exposed mainly through ingestions, also inhalation, and skin contact. Now, when we talked about microplastics, they have been detected in a wide range of scenarios. We're talking about stool, placenta, breast milk, and even more. Despite this, we don't yet have the standardized ways to measure them or monitor them actually. So that's the lack of monitored stools had led back to a regulatory response, and this gap is what makes really important understanding the microplastic exposures. Hopefully, this is a really good guy. Now, let's start talking about the digestive system. Now, a study by Yang in 2021 found that patients with inflammatory bowel diseases had a significantly more microplastics in their feces than the healthy individuals. This was in correlation with a 41.0 particles per gram versus a 28 particle per gram. Now that's a big difference. The particles mostly come from food packages, in plastics, and water bottles. Actually, just myself was drinking water right now, so here's one. Now, this isn't just a passive presence. And then, a 2027 research showed that microplastics can accumulate in the liver also, kidney, and intestines of mice, whether they can cause damage and stay embedded, potentially disrupting organs functions over time. This is really important as we see here, and we're going to be talking about it throughout the presentation. Now, when we look at this study and when we look at this graph, we can visualize this. This confirm that microplasticles are in vital organs like the liver and the kidney. Now, the damage wasn't subtle. There was oxidative stress and visible intestinal damage. Now, these findings mirror what we suspect happen in humans, and they point to chronic low-level exposures having long-term biological effects. As we see here on the left, we can see that the liver has essentially microplastics of 20 millimeters, and as you go up, you can see that there's a 5 milligram right there. When you go into the kidneys, you can kind of see that the fluorescent ones are essentially the microplastics. They essentially put them in fluorescence dye, so you can kind of visualize them. So this is actually telling us that we do have microplastics inside of us and essentially can damage and can be harmful for us. Now, when we look at research, there was a specific research done by SWAP in 2019 that found that microplastics are in 100% of the stool samples from every adult participant. The most common types were polypyrrolidine and PET, and they were mostly fragments and films. That means that they were about a 5 millimeter, maybe even smaller than that. This suggests that we were constantly ingesting microplastics from our diets, meaning food, water, and while some of those are excreted, many accumulate inside of us, essentially traveling to other parts of the organs. For me, this is a silent way, an invisible exposure that is happening every day. You don't know what's going on. It's essentially traveling to all your organs. Now, by far, there has to be one of the most disturbing findings out there. Now, microplastics were found in all placentas from pregnancies affected by uterine growth restriction, also known as IUGR, but only 10% of healthy ones. On average, there were 14.6 plastic particles per IUGR placenta. That is a direct threat to the fetal development. Microplastics were concentrated in the chronic villi. You might be asking, what the hell is that? Well, that's a structure that is responsible for nutrients and gas exchange between the mother and the fetus. Oh my God, that's crazy. So that essentially is going to likely impact the development of the child. So there is studies that confirm this, and one of them is mice exposures to the microplastics that show restricted fetal growth and disrupted placenta function, again leading to a problem in the child's development and growth as he goes older and older. And so there are connotations with microplastic reproductive tissue and placenta. As you can see, we have the graph that it goes up and off as the particles lower and lower increases. That is going to essentially damage, and even more impactful things can happen. Now, yes, once microplastics are inside, they just don't sit passively. They essentially are going to be causing real inflammation and oxidized stress. There's actually a model right here in zebrafishes models where exposure caused gut villi thinning, higher levels of reactive oxygen in species, and disrupted gut microbiota. Bacteria diversity decrease, and strains linked to inflammation increase. This affects minor those seen in human in gastrointestinal disorders like IBD. Now, chronic exposure like this weakens the immune system, balances, and could raise the risk of autoimmune or metabolic diseases. As we see here in the graph, that can potentially be happening to humans if we don't take care of that. So yes, microplastics are not just sitting passively. It can impact us in many different ways. And one of those ways that it can impact us is by the fact that it can disrupt our microbiota. It can disrupt our bacteria within our own body, essentially causing gastrointestinal problems and essentially creating an immune system that's going to be attacking our own body. So while sometimes you might have it sitting there, that can cause a lot more harm. Even if it's just not, even if it doesn't stay for too long, it can still cause harm no matter what. Now, as we talked about microplastics in a human stool samples, Heart and Body Maple, a research done in 2022, reviewed over 20 studies and found that microplastics disrupts gut microbiota balance. And as we talked in our previous slide, we mentioned how passively microplastics are also damaging our body because they create problems within our bacteria, creating autoimmune problems, essentially attacking our own cells. Now, they suppress the good bacteria like the lactobacillus and allows inflammatory ones like proteobacteria to thrive. So this is essentially how the autoimmune resistance kind of works in, right? Now, microplastics also act like sponges, carrying pathogens into the body. This combination overstimulates the immune system, leading to the release of pro-inflammatory cytokines and breaking down the intestinal barriers. It's not just an irritation, it's a full biological response that echoes chronologic gut conditions. Here you have it. Now, we're going to go back and talk about our human evidence. We kind of mentioned before in terms of 40.1 micromillimeters in the gut and also versus the 28 in highly controlled environments, right? Now, Yang, the research that was done in 2021, not only found more microplastics in IBD patients, but by showing correlation between particles count and disease severity, right? Now, that means that the worse the IBD, the more microplastics found. However, this doesn't prove causation, but it does suggest a strong relationship. Pretty accurate, right? Microplastics might be worse in gut diseases or be harder to eliminate in those already affected by it. Now, either way, microplastics could become key biomarkers for gastrointestinal illness. So that's something that we should definitely look at. Now, I wasn't just talking out of just talking, right? When we look back and we monitor what actually is going on in the evidence, we monitor confirms the presence of microplastics across the entire body. Stool, lungs, blood, breast milk, even semen. I know, that is crazy. Now, Zudi, a research study done in 2023, synthesized 91 studies finding microplastics in nearly every human tissue type. For instance, IUUGR placentas had 50 more times that microplasticals than a healthy one, in terms of 302 versus 6. The fact that microplastics can move synthetically in the body is a game changer. But we don't yet have the standard methods to detect them in patients. This makes it harder for the public health officials to act even when the data is clear. And as we see here in the graph, we can see that the stool samples in adults are higher, and stool samples in infants are actually almost as high as adults, and they're in placenta, as well as breast milk and testes. So my confirms in my studies are actually showing what it's saying here. Now, I kind of want to mention that this slide essentially relays the evidence that I previously talked in the other slide, such as including stool and blood, placenta, lungs, breast milk, and also semen. Now, we also talked about the IEGR placentas that show significantly higher microplastic counts, and we talked about the minor monitor data that supports all the systematic microplastic translation. Hope you like it. Now, despite all of this, awareness is very low. A 2025 study by Hartley found that while 79% of parents have heard of microplastics, only 11% knew that they could end up in the human tissue. However, 98% said that they changed their habit if microplastics were proven harmful to babies. For me, that is a crazy statement. Because essentially you're saying you have type 2 diabetes, you have to change your diet, but then they say, prove me wrong, or otherwise I'm going to die. Now, that shows a huge opportunity because at the end of the day, we need public education, detection standards, and stronger health communication. We're behind on this, but people are willing to act once they are actually informed. So within my end of closing in all this, microplastics are just not an environmental issue anymore. They are inside our bodies, affecting inflammation, microbia, and organ development. The burden is the highest among vulnerable groups, essentially pregnant women and the chronically ill. To move forward, we need three things: standardized monitoring, more long-term studies, and clear public messaging. This is not just about reproducing plastic use, it's about protecting human health. So with that being said, I hope you like my presentation. Thank you for listening to me, and I appreciate it.